Hi, this is Mr. Cranier. We're talking about benchmark 24, solving right triangles with the added application. The only thing we're going to do today is solving the problems involving angles of elevation and depression. We're going to use right triangles. We're going to use the trig ratios. Okay, welcome back. This is example 1, angle of elevation. So what we're going to talk about today is a circus act. So at the circus, a person in the audience at ground level, he watches this high wire routine. The acrobat is 5 foot 6 inches and is standing on a platform that's about 25 feet off the ground. How far is that audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees? And the first strategy is pretty much you have to draw this diagram. So this is what the diagram looks like. So as you can see, here is the audience member, and he is pretty much looking up to the acrobat's head. So here's the member, and what we want to do is we want to try to figure out how far is the audience member to the platform. So let's do some things. We know sine, cosine, tangent ratio. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So let's go ahead, let's figure out what we have here. When we label our triangle, we have our opposite. We don't have our hypotenuse. And we have our adjacent. Well, we're trying to figure out our adjacent. So the only thing that we have given is we have the opposite side, and we try to figure out the adjacent. So definition that will work will be tangent. We'll take our time to set this up. So tangent 27 degrees is going to equal the distance 5.5 plus 20, 25. So let's go ahead. Opposite is going to be 30.5, and then the adjacent is x. And we want to solve for x here. And it's going to take a little bit of time, but we're going to get this. We're going to multiply both sides by x. Those x's will cancel. Do the same thing on the other side. So this is what you're going to get. So you're going to have x tangent 27 equals 30.5. Again, we want to solve for x, so we have to divide both sides by 27. Do the same thing on the other side. Divide both sides by tan 27. The tan 27s will cancel out nicely, and you're going to have x. Just plug this into your calculator. 30.5 divided by tangent 27. Make sure your calculator's in degrees. And I have 59.85. So I'm going to put down 59. I'm going to say 85. Let me just round that to 9. And the unit of measure is going to be feet. So the audience member is almost about 60 feet from the base to where he's sitting at. So I'm going to say about 6 feet. Very challenging to solve these word problems. Make sure you draw a diagram to get some, at least a visual understanding, and then we set up our trig ratios. Let me know if you have any questions. This is your chance to shine. Again, this is benchmark 24, applications of right triangles, solving right triangles. So this is a diver, and at a diving competition, a 6-foot tall diver stands atop a 32-foot platform. The front of the edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length, and the camera is set up at the opposite end of the pool, even with the pool's edge. The camera is angled so that its line of sight extends to the top of the diver's head. What's the camera's angle of elevation to the nearest degree? All right, see what you guys get. It's either A, B, C, or D. Let me know if you have any questions. Hey, welcome back. Let me go ahead and try to work with you guys on solving this problem. So the first thing I want to do is kind of reread this. But I know that there is a 32-foot platform, and we're talking about pool of water. So here goes my pool of water, and the platform is pretty much 32 feet. The diver is, here goes my platform, and my diving board right there. And it's about 5 feet right here, diving board. And the diver stands about 6 feet. Okay. And there's a camera set up right over there somewhere, right at the edge. Alright, so this camera. And the camera's angle from the top of the diver's head is something like this. And again, this is going to be my right angle. And we're going to say that angle, actually we don't know the angle. So there's my X for the angle. And the pool itself is 50 degrees. So actually might not be bad. So 50 feet there. You got the 6 feet plus the 32 feet here. So let's go ahead, let's set this up. First thing you want to do is let's label this triangle. You have an opposite. You have an adjacent. And you have no hypotenuse. So the only definition that has a tangent or an opposite and adjacent, we'll go ahead, I'll just put my little trick here. So, only one that has an opposite and adjacent is a tangent. So we're going to set this up. Tangent, what's the angle? You don't know, X equals opposite, 32 plus 6. And the pool length is 50. However, you got to consider this 5 feet difference. So it's going to be 50 minus that 5. Because really this is where our right angle is, not right there. So that's going to be 45. It's a pretty nice little look right here. So we're going to go ahead and solve this. Get X by itself. Opposite of tangent is tangent inverse. And then plug in 38 over 45. Take that, plug it into the calculator, and you should get letter C, 40 degrees. So, pretty complicated. Let me know what you guys think. Bye. Okay, welcome back. This is example 2, benchmark 24, angle of depression now. And you guys could take a little bit of time. Just go ahead and read that distance. Maria's at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52, what is the horizontal distance from the sea to the cliff, to the nearest foot? And I'll give you a second to at least draw a diagram, see what it looks like, and I'll get back to you. Hi, welcome back. Mr. Cornelius, this is example 2. Now here's the sketch of the situation. You got Maria on top of a cliff. It's 40 feet. You got the seal down here, and her angle of depression is 52. This 52 and this 52, again, we got some parallel lines here. This will be 52 only because of something called the alternate interior. Okay? We learned that first semester. Alternate interior angles. Now we want to go ahead and set this up. We have the angle here. We know the opposite. We don't know the hypotenuse. And we're trying to look for the adjacent here. So the only definition that has an opposite and adjacent, at this point you should know this, is your tangent. So you can do the SOHCAHTOA, tangent, set this up nicely, 52 equals opposite 40 over x. And your goal is to try to solve for x. I would again multiply both sides by x. This would cancel out, and then I would pretty much rewrite this. Tangent 52 equals 40, and then I'll divide both sides by tangent 52. I'll plug that into the calculator. I'm left with x equals 40 divided by tan 52. I'll go ahead and plug that in right now. 40 divided by tan 52. Make sure it's in degrees. I got 31.25. The distance from that cliff to the sea. So about 31.25. Well, if you have any questions, please let me know, and I'll try to break this down to you personally. All right, last question for this benchmark 24. All right, so you got Luisa is in a hot air balloon 30 feet above the ground. She sees a landing spot at the angle of depression of 34 degrees. What's the horizontal distance between the hot air balloon and the landing spot to the nearest foot? Right. Good luck. Hope you do well on this one. Just wait around for a moment, and then go ahead and give some explanation. Back. Here goes the quick sketch on the hot air balloon, 30 feet above the ground, and she is in the hot air balloon, and she sees it with a depression. Here's my angle of depression right there. Angle of depression at 34 degrees. If this is 34, this is going to be 34 alternate interior angles. And we're asking what's the distance, the horizontal distance, between the hot air balloon and the landing spot. So this is my landing spot. Okay, let's set this up. First thing I'm going to do is label this triangle. Here's my hypotenuse. Here's my opposite. Here's my adjacent. The only thing that has opposite and adjacent is, you guys already know this, tangent. So tangent 34 equals opposite 30 over x. I'm going to go ahead and set this up nicely. Times x on both sides. And then you're going to get 34 there equals 30. And then again, one last step, you want to divide both sides by tan 34 to get x by itself. And then final answer, what you're going to get at the end of this, it's going to be 44 feet. Right, so if you have any questions on this last example, please let me know. Finish up the assignments that are due, and then our benchmark will be on word problems. Have a good one. Talk to you later. Bye.